Hey everybody, it's Mr. Carr again. Today we're going to be starting Unit 4, which is about rational functions. In this setup, we're going to be talking about what are rational expressions, as well as how to multiply and divide them. Okay, so thinking back to just fractions, these are technically rational expressions. This is all within numbers. So if I wanted to do this, especially without a calculator, I would look for certain things to, I like to simplify first before I multiply through. Technically, you can just multiply across like left to right and do 4 times 5 and 5 times 8. But personally, I'm going to do it this way. I'm going to check vertically if I can divide anything out. 4 and 5, 5 and 8, no common factors. But then I can look diagonally. So 4 and 8 are both divisible by 4. So divide by 4 is 1, divide by 4 is 2. Same thing with 5 and 5. I can divide those out, I get 1 and 1. What's left is 1 times 1 for 1. 1 times 2 is 2, so it's 1 over 2. Remember, with fractions and division, we have to do like a keep, change, flip. We keep the first fraction, we change our division to multiplication, and then we flip our second fraction. From here, I could do the same kind of steps. So I look at 3 and 9, divide by 3 is 1, divide by 3 is 3. 4 and 8, I can divide those out. So I could divide 4 divided by 4 is 1, 8 divided by 4 is 2. 1 times 2 gives me 2, 1 times 3 gives me 3. So my answer here is 2/3. What we're going to do here is very similar. It's just how we're going to add a little bit extra with our variables and our exponents, basically. So when we look at this one, we can look to simplify vertically, we can simplify diagonally, and then we multiply across when we're done. So for example, 8 over 2, I could divide by 2 is 1, divide by 2 is 4. If I look at x cubed over x here, I could divide that out. So it subtracts 1, making this an x squared now. I've got y and y squared, so I can divide that out. So this turns into y to the first down underneath. When I look at the next one, 7 and 4 do not simplify. So I got x to the fourth, and I got y to the third over y to the first. So I'll do -1 here, get rid of that. So I have y squared. I can also start looking diagonally. Well, you know what? Let me rewrite this for now. So what I have is 4x squared over y multiplied by 7x to the fourth y squared over 4. So from here, let me look diagonally. I've got 4 and 4. If I divide that out, I get 1 and 1. I also have y and y squared. So if I divide that out, I get 2 minus 1 here. It gives me y to the first. So now I'm going to be simplified down to x squared times 7x to the fourth times y to the first. Finally, let me just do my normal multiplication here, just like with my exponent properties. So I can do x squared times x to the fourth. So I'm going to get 7x to the sixth and times y. So this whole thing here through my operations simplifies to this. Okay. So that is our basic multiplication. We can also do simplifying with our rational expressions like this, where we have two quadratics instead. When you're working with this, always factor when possible. Okay, so you're looking for factoring here. In my numerator, that's x squared has to come from an x times x, -15 with a -2 here. The only way to get that is if it's a -5 and a +3. In my denominator, I've got x squared minus 9, so that has to be x minus 3, x plus 3, because it's the difference of two squares. When we do our simplifying with fractions, we're always looking for common factors. Like what I did earlier, I had like 4 and 8. They have a 4 for a common factor. Works the same way here. Since I'm in factored form, these are all factors. So if I have x plus 3 divided by x plus 3, they are going to cancel each other out. It's basically, this is the same as saying 5 divided by 5. This turns into a 1. All that's left now is x minus 5 over x minus 3. And that's it. You cannot combine anything else here. You cannot take x over x. It is a factor of x minus 5 and x minus 3. It is not just x divided by x here. So this problem is done. So when I combine that with like a multiplication kind of problem, we're going to do the same ideas. Step 1, factor though. Just factor it all out as best as I can. So when I do that, I've got x squared, -3x, -10. So that's going to be a -5 and a +2. We just did one of these x like this right here. So that's an x minus 5, x plus 3. Over here, we're going to multiply by, if I have x squared, I've got x, I don't like where that is. Let's try that again. We got x and x multiplies to 21, adds to 10. That's a positive 3 and a positive 7. And then all over x minus 2. So just like with my fractions, I'm going to start by looking vertically. X minus 5 cancels out with x minus 5. And that's it vertically. Like x plus 2, x plus 3 do not cancel. Then we got x plus 3, x plus 7, x minus 2. Those do not cancel vertically. But then I could look diagonally. X plus 3 matches up with x plus 3, so let's cancel those. Nothing else cancels. Plus 2 and minus 2 do not cancel each other out. So I'm just going to write it out as x plus 2, x plus 7 over x minus 2. And that's my multiplication there. You could, if you really wanted to, go ahead and distribute the numerator. It's not necessary. We'll just leave it like this. Okay, division. Just like with our regular fractions, division has to turn into a multiplication problem. Okay, so my first step is to just do this. Keep the first fraction, change the sign to multiplication, flip the second fraction. Okay, let's write that a little bit better. So now, just it's a multiplication problem. It's just like the previous ones. Go ahead and factor out and start coming up with ways to simplify from there. So 7x is done like it is. 2x and 10, don't forget about GCF factoring. 2 and 10 are common factors for, or 2 is a common factor for 2 and 10. So I'm going to be left with 2 times x minus 5. Over here, I've got x squared. So that has to be an x and x. Negative 11 and a positive 30 is going to be a negative 6 and a negative 5 because those multiply to 30. They add up to a negative 11. In my denominator now, same thing as the earlier one. I'm looking for a GCF here. That is x times x minus 6. Let's simplify out before we multiply everything through. So I look vertically, I got an x minus 6 over an x minus 6 here. Then I can start looking diagonally. So I have an x minus 5, x minus 5. And this is also important. X will cancel out with that x. Okay, that's like x divided by x there, but not the 7. Keep the 7 there. So you notice all of my variables are gone. All I have left is 7 over 2. And that's it. Okay, one more example here. Same thing. It's a division problem, so we're going to turn it into a multiplication problem first, because this is technically over 1. It's going to turn into 6x squared plus x minus 15 over 4x squared multiplied by 1 over 3x squared plus 5x. Now I'll go through and factor. I'm going to come back to 6x squared minus plus x minus 15 in a second here. So I'm just going to do this part, 1 over, this can be an x times 3x plus 5. Okay, so I do my GCF factoring there. With this one, don't forget, with the 6 and the negative 15, there is a like AC method for factoring if you want to do that. Otherwise, guess and check could be a way to go. It's a little bit tricky with guess and check, but I kind of already know where it's going to go. So it's going to be 3x plus 5, and then x or 2x minus 3. Because in this case, I've got negative 9x, positive 10x, gives me my positive x in the middle. Okay, so now I can look for common factors, like 3x plus 5 is a common factor with 3x plus 5. And that's it. So everything else is just going to multiply through. My numerator, I'm going to have 2x minus 3. My denominator, I'm going to have 4 times x squared times x. So that turns into 4x cubed. And that's it. Again, I cannot factor this any further. I cannot reduce this or anything. It almost is tempting to do 2 and 4, but this is the entire factor. So like 2, 3, and 4 would all to be divisible by the same thing, which they're not. Okay, so that is it for day 1. So again, we're just doing our multiplying and dividing. Pretty much everything falls in the same patterns as multiplying, dividing fractions. Okay, multiplying fractions, we're looking for common factors that we can reduce by, and then just multiply across the numerator and across the denominator. Division turns into a multiplication by flipping to that reciprocal. And then we do the same steps as we did for multiplication. All right, that's it for today. Take care, everyone.